Assalamualaikum and good morning Sir Ruzaini. My name is Fahad Ishad. I am from Group 9, DEK S1 G2. Okay, these are our group member, which is Han Xiaozuan, Ninggesh anak lelaki Manogaran, and Makmuruddin bin Basri. Today we are about to present about digital clock PBL project. For introduction, clocks are widely used in everyone's life. To be more detailed about these clocks, one day is divided into 24 hours, and 1 hour is divided into 60 minutes, and 1 minute is divided into 60 seconds. Okay, but now this project, we are about to focus on building a digital clock that can count time daily. Okay, digital clocks have more feature than analog clocks. Okay, that is why we choose to build digital clocks. Okay, digital clocks are easier to read than analog clocks. It does not require any special training to read it. Children are even more interested in digital clocks compared to analog clocks. Okay. This is our problem statement. Okay, each of us is reliant on the clock's display. Okay, this means that time is being more valuable than money because each other people, everyone is reliant to read clocks to tell they what time is it. Okay, our habit of checking the time every minute increase significantly. Okay, unfortunately, there will be issues for user of analog clocks, which is analog clocks only display some numbers that is not detailed like digital clocks. Okay, it will be difficult for who are in hurry to check the time. Okay, another issue is analog clocks are difficult to maintain. Its maintenance are difficult. Okay, next, our objective in this PBL project is to design a digital clock system using an MC68000 assembly program. It was decided that the clock should have displayed the hour, minutes and seconds. Okay, to be more detailed so the users can read it easily. Okay, next, list the program's input into IDE 68K and the program's output after the execution. Then the output will show whether the program is success or not. Okay, that is all from me. Thank you.
Good evening to Encik Ruzaini. I'm Lingesh. So today I'm going to present about the system description of our project digital clock. So we have the components associated with the digital clock. So there are some components that all clocks have in common. The first one is power supply or source. The second one is a time base or counter that keeps time and is the heart of the clock or its heartbeat. The third one is components which break down the time base into components such as seconds, minutes and hours. And the last one is some way of displaying the time, which is digital uses a lighted display. Instead of using mechanical components, digital clocks use all electronic components to perform basic timekeeping functions. For example, digital clocks rely on an electronic power supply, which can be either AC power from a wall outlet or a battery. Furthermore, it has an electronic time base that ticks at a precise rate. A digital clock also has an electronic gear mechanism known as a counter. Finally, for the display, the digital clock typically uses one of two kinds of lights, and it will use either light emitting diodes, which is LED, or liquid crystal display, which is LCD, to display the lighted time. So next we have the principle of operation for the digital clock. So first of all, the oscillator is usually provided in a digital clock by using a glass crystal. The crystal will change shape slightly and make a very little sound as an electrical charge passes through it. The sound is converted into an electronic signal after it is heard at a regular frequency, and then the oscillations of a 60 Hz oscillator are reduced to a 1 Hz oscillation by using a series of counters. Then one for each set of 10 oscillations will be counted by the first counter, and 1 for each set of 6 tens will be counted by the second counter oscillations. This sets up the 1 Hz signal so that it can pass seconds, and since it counts for 6 sets of 10 or 60, the 6th counter sets the hours. Each counter is connected to an electronic chip that sends signals to the display, which displays the time using lights. And finally, the digital clock also resets or restarts when it reaches 12:59 and then goes to 1. A built-in process is built into the electric components of digital clock, which basically looks for 13 in the hours display. When this happens, the counter is reset to 1. Okay, and finally we have the schematic diagram for the digital clock. So as you can see here, we are using 5 volt of power supply through the crystal oscillator. So it will goes through the 2 counters which I mentioned earlier. So we have counter number 1 and counter number 2, and it will go through quad OR gate, and it will go through the 6 dual decade counter, and this 6 dual decade counter will set the time, which is the hours, minutes and the seconds for our digital clock. And finally it will go through the 7 segment decoders, which is IC4543, and we have 6 of them. And finally it will goes through the 7 segment display, and the number will be displayed by the 7 segment display. And that's all from me. Thank you.
Good morning, sir. My name is San Shoshan, and now I will continue to present the flowchart in operation. So this is a flowchart for the setup the display type of digital clock. So first we will receive the input from the command line. If the command is not valid, we will continue to receive the input until it is valid. And after that, we will come to the first subroutine, which is a setup for the display on the 7 segment. First, we need to initialize the pattern of the digit in the hexadecimal form, and we need to map the pattern of the time. And after that, we need to set up all the digits to the minus sign. And after that, we need to reset all the last time digit to the hexa A, and we will return back to the second subroutine, which is the setup for the times. First, we need to change the time from centisecond to second, and after that, we need to divide the second up into the value of each digit, and to extract the next digit value from the time. Furthermore, we need to compare each of the digits. If there is any difference, we need to change the digit and back to the start, means that we need to loop again this process, and there is not any difference, we will directly to loop the process. And after that, we will display the time. So as we can see here, the first subroutine, which is the setup for the display on the 7 segment, just need to run once, because this is just to initialize and set up for the display. But the setup for the time, we need to run non-stop, because this process makes us can always update our time. So this is a flowchart for the time. So first, start and display on the screen, and we will display the second. Increase the second by +1, and we will display the second, and we will return back. Return to here, and now we need to do a decision, which is is it a 60 second? If there is yes, we will clear the second to 00, but there is no, we will display the seconds again, means +1 again, and display the second and return back. So after that, same goes, we will display the minutes, like +1, display the minutes and return back. Is it a 30 minute? Yes, clear the minutes to 00 and display the hours. And is it 24 hours? Yes, clear the hours and return back to the second. Okay, so this is our coding, and I will show more details in the EasySDK software, and this is the result. So this is the program we run in the EasySDK software, and I will run it. This is the hardware for the EasySDK, and first, as we can see, we start, and we need to set up for the display. So as we can see here, first time setup TC.byte 0002, and the 04 is missing here because this is the place of the 00 in the 7 segment display. 02 and the 04. We ignore the 04 because we need some spacing between the hours, minutes, and the seconds. So this is the 0E. So we just have the 00, 02, 06, 08, 0C, and 0E. While the time character is 3F. What is the meaning of 3F is because we need to show the digits, the type digit in this 7 display. So we need to know what is the pattern in this segment display, but the pattern is in the binary form. So we need to transfer it into the hexa. And we know that 0 is equal to the 3F. The pattern is 3F. 1 is 06, 2 is 5B, 3 is 4F, and so on like this. After that, we continue the process, like we need to set all the digits to the 0A to make it can always add the digits, the Thai digits. And after that, the main progress will start on in and the Thai display and also the Thai digit. These three subroutine will continue to loop because we need to always add our time. And now I will show how the hardware run like this. So for me, thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Makmuruddin bin Masri and I will continue the presentation for discussion and conclusion. Okay, firstly in discussion, to operate a digital clock which consists of hour, minutes and second in 7 segment display, we have to get the pointer to the character pattern table, variable, digit index table, initialize display and update all of the clock digit and set the time loop. After that, at the first digit match the loop is as all remaining digit will be the same, and the command also makes the hour, minute and second digit index and copies the segment pattern to display and return to the main loop. And we also have to make spacing between the time, which is hour, space, minute and second. And we also have to set up hardware to display the hardware window and display address and also do the I/O function. And lastly, the segment pattern to display the number 0 to 9 are made by summing the 2 multiplied by n value, or we call it hexadecimal number. And lastly, the program will continue to cycle in endless loop. For the conclusion, the system of digital clock also have many advantages, like in term of cost of the product, easy to understand time concept, give time more accurately than analog clock, and easier to read time. Okay, as a result, the system of digital clock is expected to be normal and with desired accuracy. And we hope that the habit of checking the time every minute increase significantly. Okay, that's all from us. Thank you.